Imagine trying to solve a complex puzzle using pieces from different boxes. Some from biology, others from computer science, maybe even a few from philosophy or economics. That is the nature of interdisciplinary research. It brings together knowledge, methods, and perspectives from multiple fields to answer questions that no single discipline can fully address on its own. But to unlock insights in such rich and varied territory, you need a clear and purposeful starting point: a well-formulated hypothesis. At first, formulating a hypothesis might seem straightforward, just make an educated guess, but in interdisciplinary studies, it is more like designing a bridge between different intellectual worlds. You are not just asking, what might happen? You are asking, what can I reasonably expect to happen based on multiple theories that were never meant to talk to each other? This makes hypothesis formulation both more challenging and more creative. So what makes a good hypothesis in this context? First, it must be clear and testable, a basic rule in all science. But more importantly, it must translate between disciplines. For example, imagine a study that combines neuroscience and architecture to examine how the design of buildings affects cognitive stress. Neuroscience might frame questions in terms of brain activity, while architecture talks about spatial layout and light exposure. A strong hypothesis here would connect the two by predicting a specific brain pattern, say increased amygdala activation in response to certain architectural features, like low ceilings or poor lighting. In other words, the hypothesis acts as a lingua franca, bridging jargon and assumptions from each field. One best practice is to start with a shared conceptual framework. Instead of diving straight into data, ask, what do these disciplines have in common? Are they both interested in systems, patterns, behaviors, or outcomes? Finding that common ground can help you build a logical, interdisciplinary rationale. This often involves reading broadly, looking at not just what each field says, but how it defines success, causality, and evidence. Only then can you shape a hypothesis that respects the rules of multiple games at once. Another useful strategy is to involve collaborators from the beginning. If you are working with experts from different domains, bring them into the hypothesis formulation stage. Ask them how they would frame the problem from their disciplinary lens. Then, synthesize their perspectives into a unified research question. This not only improves the hypothesis, but ensures that your study will make sense to all stakeholders involved. Clarity matters more than complexity. A common trap in interdisciplinary research is trying to include too much in one hypothesis, stacking variables and theories like a tower of Jenga blocks. Resist this. The most effective hypotheses are those that are specific, focused, and anchored in observable outcomes. If your question is, how does urban noise affect learning in children with AD? Make sure your hypothesis pinpoints the mechanism, e.g., distraction due to increased cognitive load, the measurement EEG test scores or EEG patterns, and the expected result, e.g., lower performance in noisy settings. This makes your work replicable and grounded even in a hybrid research setting. Have you thought about how your hypothesis could evolve? In interdisciplinary work, flexibility is crucial. New insights from one domain may require adjusting your original assumption. Rather than seeing this as a weakness, treat it as a sign that your hypothesis is alive, responding to new connections, models, or data. Some of the most groundbreaking discoveries emerge not from rigid testing, but from adaptive hypotheses that grow with the research. Finally, reflect on why your hypothesis matters. Interdisciplinary studies often aim to solve real-world problems: climate change, mental health, digital ethics, where the stakes are high and the variables are many. A strong hypothesis should not just be testable, it should be relevant, grounded in the complexities of human experience and oriented toward actionable understanding. In the end, formulating a hypothesis in interdisciplinary research is not just a technical step, it is a creative act of translation, synthesis, and foresight. Done well, it becomes the compass that guides the whole journey, allowing you to chart a course through the tangled web of knowledge and find something new, unexpected, and valuable. So the next time you sit down to write a research question across disciplines, ask yourself, does this hypothesis connect worlds? Does it invite testing, and does it make a difference? If the answer is yes, you are on the right track. A hypothesis is a testable, falsifiable statement that predicts the relationship between variables and serves as a foundational element in scientific research. In interdisciplinary studies, hypothesis formulation must integrate concepts and assumptions from multiple fields, harmonizing differing terminologies, models, and epistemologies, resulting in a clear, concise statement aligned with measurable outcomes from each contributing discipline. In studying climate impacts on public health, for example, a hypothesis might connect atmospheric CO2 data, environmental science, with disease incidence patterns, epidemiology. It's like designing a bridge. You must connect two distinct shores using materials strong enough to support traffic from both sides. Different disciplines often operate under distinct paradigms, assumptions, and methods of reasoning. What counts as evidence in one field may be anecdote in another. So, interdisciplinary hypothesis formulation must begin by acknowledging and reconciling these epistemological differences through clarity in definitions, units of analysis, and levels of abstraction. A psychologist's focus on individual cognition and an economist's on population behavior must be unified under a common scale of measurement. It's like translating between languages with different alphabets. Before writing a sentence together, you need to agree on what the words mean. The best interdisciplinary hypotheses arise from identifying shared constructs or boundary objects, concepts that carry meaning across fields while retaining flexibility, thereby aligning data collection and analysis methods. For instance, in neuroeconomics, reward functions both as a psychological concept and a quantifiable economic utility, allowing a testable hypothesis bridging brain activity and decision theory. It's like finding a common thread between two fabrics. Only then can you sew them together into a seamless piece. Interdisciplinary hypotheses must clearly define expected causal or correlational relationships and map mechanistic pathways to show how variables from one field influence those in another, using diagrams or logic models to avoid ambiguity and ensure falsifiability. For example, a hypothesis that urban greening reduces stress links environmental exposure, urban planning, to biomarkers of stress, biology, through specified physiological pathways. It's like explaining how a relay race works, not just who runs, but how the baton is passed between runners from different teams. A hypothesis must be operationalizable across disciplines by translating theoretical terms into measurable indicators acceptable to each field, preventing partial testing or inconsistent interpretation. In studying innovation ecosystems, collaboration might be quantified through social network analysis, sociology. It's like building a universal remote control. You must ensure it interfaces correctly with each device, even if they were built by different manufacturers. Interdisciplinary hypotheses should avoid overgeneralization and reductionism by accommodating complexity while focusing on tractable, testable components. Instead of flattening one discipline's framework onto another, a layered hypothesis might posit that economic factors moderate but do not solely determine cultural change. It's like adjusting the brightness of a layered photograph. You do not want to lose detail in the shadows just to highlight one feature. The most robust interdisciplinary hypotheses emerge through collaborative formulation, where researchers co-develop ideas via iterative discussion, critique, and refinement, often using visual models and cross-disciplinary literature reviews, and build consensus early on about meaningful evidence. In environmental humanities, for instance, scientists and historians work together to hypothesize how climate records and textual archives reveal changing perceptions of nature. It's like composing a symphony. Each instrument must harmonize during rehearsal, not be spliced together during the performance. Formulating a testable interdisciplinary hypothesis also requires addressing methodological compatibility and limitations, since some fields use experiments while others rely on qualitative inference or simulation. Hybrid methodologies, such as combining sensor-based traffic data, engineering with resident interviews, urban sociology, must synchronize without short-circuiting each domain's standards. It's like building a hybrid car. You need both an electric motor and a combustion engine to work in sync without failure. AI tools, including natural language processing, knowledge graphs, and generative models, are increasingly central to interdisciplinary hypothesis generation by integrating vast datasets across fields, uncovering latent variables, and suggesting novel connections that human researchers then interpret and validate. For example, language models scan biology and materials science literature to propose hypotheses for bio-inspired material synthesis. It's like using a telescope that sees in multiple spectra. AI helps detect patterns invisible to individual disciplines looking through their own lenses.